Stop applying randomly to jobs and learn how to get a remote job the easiest way. Click the link in the description to unlock it for free. Now you already know what are the exceptions and the most common ones. Let's now simulate some exceptions and use some keywords that Python provides us to handle these exceptions and to present some more friendly messages, or even to do new operations based on the exceptions that may happen. All right, so type a fruit to get the price. We are going to put this input here in order to the user to type the name of the fruit that the user wants to know the price. We are obviously assigning to a variable called fruit, and instead of printing the fruit and getting the hard-coded key, we are going to change this to the variable fruit. All right, let's run and see what happens. If I type apple, it's going to return the price. Okay, but if I type grape, we know that it is going to raise an exception, right? The exception key error, because there is no grape in my dictionary. We already know that when we try to get a value using a key that doesn't exist, Python returns the key error. So as I know that this can happen, I see this line as a risky line of code, as a dangerous line of code. Because if the user types a key that exists in my dictionary, it is going to work. But what if the user types a key that doesn't exist? It is going to cause the key error. So this characterizes this line of code as a dangerous line of code. And when I identify some line or some block of code as risky, as dangerous, I can use the keyword try instead of only writing the line of code. I can write the line of code inside of this try keyword block. So now, instead of running this line of code, Python is going to try to run this line of code. If some error happens, we can use the keyword except to print a more friendly message. For example, like an error has occurred. That's how you spell it. I don't know, but you got it. So this is basically how you handle dangerous and risky lines of code. Let's try it. If I type grape, instead of having that raw error of Python, I can tell my user that an error has occurred. All right, but this is too generic. Do you agree with me that this way of handling errors is too generic? Because we already know what is the specific exception that this may return. We know that it's the key error exception. So instead of only writing the except keyword, we are going to write except key error, and we are going to put a more specific message here, like fruit unavailable. So now the user knows what really happened, because the user don't know what is a key error, but the user know that if grape was typed and the message is fruit unavailable, now the user knows exactly what is the problem. Okay, if we run a fruit that exists, we're going to see that we're going to get the price normally. All right, and you can implement this except with the name of the exception that you already identified that your previous line may cause to every exception that you know. And even if you don't know some exception, in this case you can implement the except, the generic except, like some problem has occurred. Alright, so this way you can add more than one except block. If your code breaks because of another reason that is not the key error, it is going to print this message. Okay, let's simulate another situation here. Let's pretend that we have a feature that allows the person to split the bill. How many people are splitting the bill? Let's parse because this is a number, and let's put here the price. And let's put here the value splitted per person. All right, so splitted value, it is going to be price splitted value receives price divided by split bill. So here we're going to print the splitted value. Our logic is right, but can you see the probable exception that this block can cause? What if the user passes 0 as a parameter here? It is going to raise the zero division error. And in this case, it is not going to print fruit unavailable because it's not a key error exception, and is going to print some problem has occurred. Right? So let's check if this is really what's gonna happen. So type of fruit, apple. How many people are splitting the bill? 0. Some problem has occurred, right? Because Python tried to execute this block. This line worked because I passed apple. If I passed grape, it immediately was going to throw this exception here. But I passed a fruit that existed, so it got the price, right? And in the price attribution, it works. But in this line right here, Python tried to divide the price by 0. And we know that it's not possible to divide any value by 0, right? So we could add the except zero division error and print the specific error here, like you cannot divide by 0. Divide your bill by 0. Okay, let's now try to run the same scenario. So apple How many people are going to split the bill? 0. You cannot divide your bill by 0. So now we have a specific message that occurred in the same block. You know, inside of this try block here, anything that goes wrong is going to throw an exception. And as we know, the except keyword and the most common exceptions, by writing our code, we can anticipate the probable exceptions that are going to be raised and write friendly warnings to our user, and only use the generic except to cover the scenarios that we didn't notice that could happen. So that's how you use the try and the except keywords to handle your exceptions. There's a simple process to getting remote developer jobs that nobody teaches. I broke it down in a free training that you can unlock in the link below.